Hi everyone. Today we'll speak to you about a new smart contracting language named Gno.land, which is not in Ethereum, not in the EVM world, but aims to be an alternative that will connect to Ethereum in the near future. So to get started, I will speak about the history of smart contract starting 30 years ago, when it was just a concept, so before the blockchains, a concept not as the piece of code you name a contract, but as a protocol that will embed the source code, the execution, the proof of execution, so that you can remove the middleman. So 30 years ago, we were using cryptography to try to remove middlemen, but it actually was not yet used in production, in blockchains, in a trustless system. But it was already designed to support financial transactions, but not only. At the origin, it was also something for social coordinations, democracy, governance, and other features where you want to have trust in what you execute. There was a nice analogy with the vending machine. So when you just give money, you get your can of Coke or whatever, and you don't need a middleman. Basically, smart contracts were designed to be like vending machine, but for any kind of source code. So 2009, Bitcoin happens, and you don't have real smart contract yet. You don't have a Turing complete machine, but the concept of programmable money becomes something. The concept of smart contract is woken up. So 20 years later, we are thinking about, okay, now we can make something with trustless, with proofs, but we can remove completely the middleman from A to Z. So it's not yet Turing complete. You can basically just have programmable money for simple instructions like multi-signature. And it gave an idea to what you know well, to Ethereum, EVM. 2015, we have a Turing-complete machine, and now it's possible to create decentralized applications, and it has a huge adoption, with more than 10 million contracts published just last year on Ethereum. So here you have something made with a new bytecode, a new language, unique for this blockchain ecosystem. 2019, we start having many new initiatives to try to compete with Solidity and EVM, both on limitation, like the stack limit or complexity, etc., but also to try to bring new developers to the smart contracting world. So we don't need anymore to learn a new language to start creating contracts. You can come from the Rust ecosystem, from Golang ecosystem or whatever, and start building contracts. So today we have a lead, which is Rust, but technically you can run a huge amount of languages. So a quick recap. 30 years ago, we have an idea. 10 years ago, we have real smart contracts with Turing-complete VMs, and the adoption is huge. So it was quick, very quick. And about Gno.land is a new ecosystem where we try to push the limits on all the current limitations and try to design a new era for smart contracts. It starts with a new language and a new VM based on an existing language, Golang. So it's a famous language to build blockchains, Web2 applications, and many kinds of applications, actually. It has its own L1 blockchain, Gno.land, which is not the only one that will support Gno.land and GnoVM, but it's the first one and will have special features. It's built on Tendermint 2, which is a new version of the famous proof-of-stake protocol that powers many blockchains, including Polygon and all the Cosmos blockchains. It has a new consensus mechanism. So all of you know proof-of-stake with Ethereum v2, but we are trying to create a new one, proof of contributions, which is basically a proof of stake without the financial incentive part. The whole goal of the ecosystem, because the vision is to make something that will stay for years, we aim for extreme simplicity, security with transparency, accountability, auditability, and we want to scale the smart contracts to make a system where you don't have any virtual limits. So today I will speak about something which relates to Solidity, more like an alternative where we try to push it to the next level. So first, we create a new language based on Go. Why Go? Go is an established language with millions of developers around the world. And we think it's a very good language in terms of features, in terms of simplicity, philosophy. So you have something simple, simple to read, simple to write, simple to maintain. You have very good security by default. Maybe you can find these languages with more security, but the one in Go is clearly a good threshold with simplicity and security. And a thing that is actually an opposite direction with other languages is that we want something garbage collected. People from Rust and other modern languages will want something without garbage collection because it will give them a lot of room for optimization. We want extreme simplicity, meaning that we took the trade-off to limit the amount of optimization you can do. So we wanted a language where you just focus on the logic and not on the optimization. So that's why we chose something which can be counterintuitive, the garbage collection. And a last very good feature about Go is how it handles objects. It's not like Solidity. It's another method using embedding and composability. The good thing about this is that for complex graph of inheritance, you can prevent conflict more easily than for Solidity or other languages. And now, why do we want to create a new language, and why don't we just use Go on blockchains? So Go is not designed for blockchains. It's designed for backends, local applications, web applications. We created a language dedicated for blockchains, so it has built-in determinism, which is not the case for Go. It's interpreted, which is not the case for Go and other languages like Solidity, because we like having an understanding of what the code will do, what will be the execution frame, what will do your import, what is the data structure. So basically, instead of taking a dependency like OpenZeppelin, at the build time, you will upload OpenZeppelin, and then you will upload a contract depending on the uploaded version of OpenZeppelin. Meaning that at the end, we will have an amount of statistics not only for the contract you call, but also for the dependencies. The VM is intuitive, which is not very important for a contract developer, but in terms of something you want to maintain over time, you want to extend, it's important to have a VM, a language that you can easily understand, debug, and extend. It has auto-persistency, which I will show you makes the life a lot easier and justify why Gno is actually a lot easier than Golang with Wasm. And it has automaticalization, which basically two things. One, to create more rich types, and two, to have Merkle tree available by default for the whole chain. So why it's an intuitive VM? If you look at Solidity, EVM, etc., you have a first language, Solidity, just designed for this use case, which is transformed into a custom bytecode, the EVM bytecode, which is also very unique for this usage. And at the end, you will have an implementation, VM implementation in another language. With Gno, we wanted to have a unique language for the contract. We wanted to have the same language to run the implementation. And in the middle, we wanted something simpler than bytecode, and we chose the default AST. So the AST is a human-readable version of your language. You have it for any other languages, and it opens doors to have better debuggability, extension, and competition against your own implementation. In terms of auto-persistency, that's where Gno will surpass a lot all the Wasm implementation with other languages. So when you develop as a developer, you have two representations of your data. You have the one in memory, the one you use for your logic, with the conditions, the loops, etc. And you have the state. Most of the programs, including in the Web2 ecosystem, will depend that you load your state, then you do your logic again over the memory, and at the end, you store the state, you save the store. The idea here is to not ask the developer to load the store, save a store, make translation between bytes and with decoders, encoders, etc. but to just focus on the logic. Meaning that we have something similar to Solidity. In Solidity, you have something equivalent. You don't have a store load, store save, you don't have decoding, encoding. Where on Gno, you won't have the obfuscation that you have with Solidity. You won't run into bytecode. You won't have a contract named 0x something, but you have something equivalent. Now look at what we can have with WASM. So this is a snippet, because there is a lot more code if you want to create a Rust WASM smart contract. But basically, you have a lot of boilerplate code around, so you have something to load your state, to save your state, to route your messages. So it's clearly more complicated than Solidity and Gno, even if Rust is a language that exists and has its own community. If you look at Go and WASM, it's very not common yet. Clearly, I think Rust is way better than Go for WASM contracts, but that's the same. So you have something equivalent to the Gno contract, except that you don't have a single line. You have many lines to load the store, to translate the binary version of your store, and do the same for storing at the end. Something we have in the Cosmos ecosystem is dApp chains. And app chains are basically blockchains that you can extend with code, with modules, that will do the same as smart contract, except they are not published on the chain. They are built in and create new verbs to your blockchain. And even here, to create a simple increment counter, you need to have 4 files and many code to load. You need to manage the determinism, etc. So even here, without WASM, with standard Go, it's harder to create contracts. Now, if you look at just simple Go, so this snippet is not Web3, it's Web2. It's just to load a file, transform the result of the file into an integer, increment the integer, and store it. Even here, you have more code. So at the end, you don't need to care about the storage, and it also works with more complex types. In the example here, the node is a complex structure that have reference to pointer to itself, to the left node, to the right node. It's a tree, and it will be stored without any problem. And it won't just be stored without problem, because it will be stored in an optimized way. You will have an automatic difference between the start and the end of your transaction, understanding the structure, and also Merkleize in a way so that you can verify what's on the chain without looking at the whole chain. So you have automatic Merkle trees for everything, which allows you to create a browser version of your a browser client that will understand the chain without having to synchronize everything. Another very big difference between Gno and WASM or even Solidity is about how we manage imports. On Solidity, for instance, you will import another contract, and you will have a call that will be limited to primitive types. You will need to pass strings, integers, and receive the same. In Gno, the goal was to make something as in Web2. When you import something, you can use the full structures, and if the structure is not a string and integer, but something with multiple levels of data, it will work very effectively and without effort. So just to give you another example, it's not expensive to call another contract from another contract. You just load the contract once, and then you can make thousands of calls. It will be basically costless. As for Solidity, we can have interfaces. So here is the equivalent of the ERC 721. You create your interface. As soon as you implement the interface, another contract can receive data from your contract, even if your contract was created after. So we have something equivalent and as easy as in Solidity. So at the end, by creating Gno, we are creating a new language, but which is already known, and we don't have, like for WASM with Rust, with Go or in other language, we don't have to relearn how to manage the state, how to manage the routing of your contract, how to, I don't know, to manage determinism. You just focus on writing simple Go code, which can even be simpler than Web2 Go code. And a good thing about this, about the automatic persistency, automatic merkleization, is that at the end you can have very more complex structures, allowing to bypass the goal of making the best DeFi applications. One of the first contracts we did was a forum, so something with comments, with a long term, with a lot of text, with authors, with ENS system equivalent, and the contract was very short, very powerful, and this is an example of how we can do more complex contract when the data structure is automatic, simple, optimized by default. So you have contracts which are very simple to read, very simple to maintain, but also that can go far further. Sorry. Another part about Gno is, since you have interpreted code, it's not possible to obfuscate your code. It's not possible to hide your code with bytecode. You don't have to decompile everything. You have the source of everything you read. Since the blockchain also understands all the interpreted code, if you have a call to a single contract which imports other contracts, the blockchain will understand this too. Meaning that with some history, if you create a new contract depending on famous libraries, for instance, an Open Zeppelin equivalent, you can review a simple new code which has imports which are already audited, already trusted. So it can also ease the discovery. I don't know for developers if you like to browse GitHub and discover projects and look at the authors, the organizations, the amount of commits, the dependencies, etc. But basically, we want to offer this. We want to offer an experience when you can easily discover what you will execute, discover what library you want to use for your own smart contracts. So at the end, you can browse, you can discover, audit, use, and fork everything which is on Gno. From day one, the goal of Gno was to not only solve simple smart contracts, but also scalable smart contracts. So in the Cosmos and IBC ecosystem, we have IBC to make inter-blockchain communication. We have ICS, which is a new feature to basically increase the security and make better Satoshi score of decentralization of your chains. And the goal with Gno is to connect to existing IBC and ICS implementations, but also to push forward. So at the end, this thing about making simple contracts that can import other contracts will be pushed to other chains. So at the end, you can expect maybe to have a chain dedicated to an ENS alternative, and you can, on your chain B, depend on and import and use the other chain and keep structures and understanding and type safety across multiple chains. So we can help solving the scalable smart contract by having maybe an internet of blockchains, which will all be specialized, maybe some for storage or memory or speed or whatever. And then some things that I talked about at the beginning. We want to create proof of contribution, so a new consensus mechanism. It's not only a way to reward people in addition to proof of stake, it's the thing that will replace proof of stake. The goal is to have a voting power and decentralization of the chain, not based on the amount of money, not something that you can trick by coming with a huge amount of money, but instead to focus on expertise and values. So by contributing to the project, to the ecosystem, you earn points, which is slow, which is harder to trick and to take over a chain. The goal is to create a voting power based on the amount of contributions, meaning that if you can vote, if you can participate, you understand the project, you involve multiple hours of your time to understand the philosophy, how it works, the backend, and everything. So we want to make something protected from financial abuses, and that will be complementary to other chains in the ecosystem, thanks to protocols like IBC, ICS. So in the future, you can expect to see Gno that works with proof of contribution connected to other chains with proof of stake, and have the best of both worlds, where you can be secured by something which is resistant to financial attacks. And for you, if you want to check out, to try out now to convert your Solidity contract to Gno, to give a try, you can visit the GitHub project, the website, Gno.land, and help us create Game of Realms. Game of Realms is an online competition we have at the moment, where the goal is to bootstrap the community of contributors. So by participating, you are helping the project to happen, and you are entering the DAO of contributors that will own the chain and the genesis of the mainnet. So by participating now, you can help earn rewards. We give some atom prices and become actors in the genesis. And the best thing to do is to contribute. So if you're a Go developer, you can contribute to the smart contract to create standard libraries, famous libraries, or to even improve the engine itself, which is also in Go. Thank you very much. I will be there if you have questions, if you want a small demo, discuss, whatever. Thank you.